So on the last page, we have 5 more problems. The first one says we want the numerical value of a particular value. So we're giving an x value there of 1294, and we want to evaluate this. And so there's 2 ways to do this, really. You can do it with a calculator, again, using the change in base formula. And I would encourage you to try that just to see what you get. But if you suspect that the answer is an exact nice number, which this probably is because it's asking for a numerical value and it's not saying round it off to 3 decimal places, then it might be easier than that. So let's just see what we would get. So g of 1294 is the log base 6 of 1 over 1296. And if you investigate 1296 a little bit, you'll see that it's divisible by 6, and then that answer is divisible by 6, and so forth. And so it actually turns out that this is log base 6 of 1 over 6 to the 4th. So 1296 turns out to be 6 to the 4th. No, you probably wouldn't recognize that, but if you just play a hunch and see if it is divisible by 6, you'll see that it keeps being divisible by 6. So, and don't forget that that 1 over 6 to the 4th is the same as 6 to the minus 4th. And so we have an exponent base 6 inside of a logarithm base 6. And so our intuition should be that the logarithm and the exponential are sort of canceling each other out. That's what inverse functions do. Same way that squaring the square root brings you back to where you started from. But if you don't recognize that, it's really not a big deal. Let me just write down here. Because remember, when we're trying to figure out exact values, we can always set this up as an equation. The log base 6 of 6 to the minus 4th equals blank, and then rewrite that using exponential form. We know that exponentially this should be 6 to something equals something, and the role of the input and output should be switched. And so the input into the exponential should be this mystery number, and the output should be 6 to the minus 4th. In other words, the thing that's inside the logarithm. Well, if you look at it in that form, then it's pretty clear that the mystery number is negative 4. If 6 to some mystery power is the same as 6 to the minus 4, then the mystery number must be minus 4. And so that's actually the answer. If you did this using the change of base formula at any point, even right off the bat here, you could just evaluate this as, you could say it's the natural log of 1 over 1296 divided by natural log of 6. So it's the log of the argument divided by the log of the base. And it turns out that'll be exactly negative 4. So it's easy enough to do in a calculator if it comes out to be an exact number. But if it is an exact number, then you can think about it in terms of just properties of exponents. Number 12, finally, 12 and 13 finally get to questions that have nothing to do with logs and exponents. This is just simple composition of functions. So don't forget the way we do that is we work inside the parentheses out, and so we first have to figure out what f of negative 2 is. So we follow the f rule for that. So f of negative 2 is 4 times negative 2 plus 4. So it's negative 8 plus 4 is negative 4. And then I have to evaluate g of negative 4, which means I've got to put the negative 4 in place of x here in the g formula. And so I'll have negative 4 squared plus 6 times negative 4 plus 4. Notice, I keep saying this, but it still ends up being problems on some of the gateways. When you're replacing a single letter with something complicated, right? This is not very complicated, but it's got 2 pieces to it, right? The negative sign and the number. So if you're replacing a single letter with something that's more than a single symbol, always carry parentheses with it. So that negative 4 goes in there, but it's going to go in with parentheses. If you do that, then if you enter that exactly in your calculator, the rules of exponents will be done correctly. So this will be 16 minus 24 plus 4, which is negative 4. So 2 questions in a row had negative 4 as an answer. What are the odds? This question asks about domain, and so this is really just a matter of remembering what functions have problems. So far we've collected 3 things that have problems. If you're dividing by a 0, that's a problem. That'll give you an error. If you try to take the square root of a negative number, that will give you an error. And if you try to compute the log, it doesn't matter what base, but the log of anything other than positive numbers, you'll get an error. And so the question here is just which of these numbers gives you an error, right, which is not in the domain. So you could just try each one. You could just try evaluating each one and see if you get an error message or not. Or you could actually try to figure out what the domain is, which shouldn't be hard. The square root function is only okay if the stuff under the square root sign, in this case minus 5x minus 20, is not negative. So this is how we write not negative. And so the domain is going to be any x for which that's true, for which the stuff under the square root sign is at least 0. And remember, square root of 0 is perfectly fine. So, so I can do that. I mean, I can add my 5x to both sides and think about it in those terms. And so negative 4 greater than or equal to x. So the domain here are just the x's that are less than or equal to negative 4. Solving inequalities is very tricky, so you want to make sure that you have that in the right direction. The easiest way to do that is just try something. If your calculations say that x should be less than or equal to negative 4, then try putting in, negative 5 or negative 10 or something, just to see if you've got that the right way around. If you do the algebra right, where you're just adding both sides and dividing on both sides, the only thing that could possibly go wrong is that you would have this backwards. And that's very easy to check. Just pick any number that you think works, and it either will or it won't, and if it doesn't, then you probably have that backwards. Anyway, so this is the domain. So if I wrote it as an interval, it would be minus infinity to minus 4, and I would put a square bracket there because I definitely want to include the possibility that I have the square root of 0. And if you look at it, all of these satisfy that, every single one of them. So the answer here is E, all of the above, because all of the answers they've given me are actually in the domain. Number 14 and 15 is using these two problems are using a common formula for that uses exponential functions. We talked about it very briefly. It's called the PERT formula, and you don't have to know it. It's on the exam. So what it's telling you is that the amount of money in your bank account, in your savings account, is given by this formula, where T is the number of years that you've left it in the account. And so that's really all you have to know, is that the input is how many years you've had it invested, and the output is the actual amount of money you have. So the A there stands for amount of money. So it'll be a dollar amount. And so in this case, they tell us a T, right? That is a number of years. So they tell me 4 years, that's a value of T. So they're telling me that T is 4, and so that means that the amount of money I have is A of 4, and I just have to plug in to my calculator this formula. Be very careful that you put all the stuff that's supposed to be raised to a power needs to be in parentheses in most calculators. So from a calculator point of view, you'll probably have something like this, e to the power, and then in parentheses 0.03 times 4, close parentheses. So you see how I have the parentheses around that entire power, because my calculator lacks the ability to just make the power like a smaller font and higher, which is what we do with the math notation. Some of your calculators actually can make things look correct, but most people, this will be the way it looks in your calculator. And so that'll be the right answer. I forget what it is, but the answers are on the, I guess. So according to the answer on the other side, it's like 1769 something. Anyway, the answer's on the last page of the handout. I forget what the number is here. It wants it to the nearest cent, so I should fill in the last 2 digits, but I don't remember what it said. And I just discovered that the calculator I'm using has the 1 button doesn't work, which is very limiting for a calculator, so I may have to throw that away. Okay, so the question 15, anyway, check the answer on the next page. On number 15, we're told that, again, we're given the formula, and the T is the same thing. So the T is in years, and this is the amount of money in dollars. The outputs are dollars, and the input are years. And now it asks how many years. So in other words, what's T so that the investment is worth $14.48? So they're telling me the output is 4418, and they're asking what input does that. And so that becomes an algebra problem, because I have to say, here's the formula for the outputs, and I want that to be equal 4418. And so I have to find t. So in other words, I'm solving this equation. And so, hang on, I got to find another calculator. See, I can't do this without a 1 button. So I'm back in business. I have a calculator with a 1. So to solve this is just a normal exponential equation. So remember, our strategy is to first isolate the exponential part, and so that's this part. That's where our variable is stuck up in that exponent. And so to do that, I'm going to divide both sides by this 3,272. If I divide both sides by that, then I'll get e to the 0.15t equals, let's see what the calculator says. Actually, I'm just going to leave it like this. This will be a little bit easier to to be sure I have the rounded correctly. So I'm just going to write it as 4418 over 3272. That's easier. I know it doesn't look nice, but it's better if I just put it in my calculator all at once. And so this is equivalent. This is an exponential function base e, and so it's equivalent to a logarithmic equation base e, where the input is this 4418 over 3272, and the output is 0.015 t. So that thing on the left, even though it's ugly, I can calculate that all at once in my calculator. And I get, let me just draw this so I can work over here. 0.3002859, looks like, give myself plenty of decimal places, is equal to 0.015 t. And so now if I divide both sides by 0.015, I'll get t equals 20.02. So remember, that's a time, that's years. They want this rounded to the nearest tenth of a year, so this is approximately 20.0 years. So the answer is that if you have a goal of saving up $4,418, starting from having $3,272, you need to have that sit in your account for 20 years in order for the account to be worth that value.